Hello, this is Michael Novinson with Information Security Media Group. We're going to be discussing network visibility, cybersecurity, and fraud detection today with Vince Stoffer. He is the Field Chief Technology Officer at Corelight. Good afternoon, Vince. How are you?
Hi, thanks for having me here, Michael.
Thank you for making the time. I want to start you off with a big picture question here. Get a
Sure.
sense of why network visibility is so important for comprehensive security coverage. Why does it
Yeah,
matter?
yeah, it's a great question. I'd say network visibility is super important for a couple reasons. The first is just to be able to have that kind of holistic picture of what's happening in your organization. A lot of organizations focus on the endpoint, focus on the hosts and the systems and the services that those systems are offering, but that leaves out a big piece of the picture of where all of that traffic is going. It's always coming or going from somewhere. So we like to say that the ground truth is really seen on the network. That includes devices that you might be able to instrument with something like EDR, but also includes all of those things like ICS, OT, BYO, all the devices that you may not have any sort of management or visibility on in another way. So network really helps with that breadth versus depth picture to have a holistic view of what's happening on your environment.
So, what are some of those otherwise unnoticed threats that can either only or primarily be found through network detection?
Yeah, good question. I mean, I think it really comes down to how some of those devices are attack vectors into the rest of the enterprise, right? So take a printer or a piece of building automation like an HVAC controller, right? These are things that people don't typically think of as being a cybersecurity risk. But of course, what we've seen with, advanced attackers is they will use any sort of tools or systems to get access and gain a foothold into your organization. So if you're able to leverage a out-of-date vulnerability in a printer and that happened to be exposed on the internet, you're probably not going to see it in any way until you get to that later attack stage, and now it's compromised and moved laterally and looked at some sort of other host that you have instrumented. So network gives you that big picture visibility and allows you to kind of put the pieces together and tell the story of maybe how did this start, how bad is it, where is it going? Are we fully cleared and remediated and ready to kind of recover, or are we still in the process of resolving this incident?
And why does the network piece help in terms of something like a printer? Why does it help, and why does that help in ways that other telemetry points maybe struggle?
Yeah, I mean, often there's just no visibility into those sorts of devices. So I think again, over reliance on endpoint is something that's kind of happened in the last few years. There's been a pendulum that swings back and forth, or kind of network to endpoint, and where that response is. And I think we've swung all the way back in the endpoint side, and now we're starting to pull back on the network side again because not just on-premise devices like the stuff we talked about, printers or ICS devices, but also in the cloud, right, where you've got big pieces of data moving back and forth. You have some level of visibility into them with those cloud providers, but network visibility and network detection and response can also give you a picture of how to tie that to how it's moving in and out of your organization, how it's moving in and out of SASE or to some of your home users or those other connection points into the enterprise.
So, I wanted to talk a little bit about artificial intelligence, generative AI. I know it's been 2 years since the general availability of ChatGPT. Want to get a sense of some of the opportunities there when it comes to streamlining workflows. How can third-party large language models help?
Yeah, it's a really interesting question. That's where we've seen it be the most effective is really in some of the areas that LLMs are particularly strong in, like summarization and correlation of kind of sources of data. I think the first thing that people would ask us as a network security provider is, oh, great, you can use LLMs to detect threats, right? And what we found is, by feeding in network traffic in the form of PCAPs or packets, feeding in alerts, even feeding in raw telemetry data and trying to get the LLMs to actually do detection and alerting, not super effective, at least not yet. It's a specialized area. It's got a bunch of you know information that you need as part of the security team to make sense of a lot of those things, and the LMs don't have that context. So we found it to be super effective in taking some of the things that we have, like alerts or rules or signatures, and trying to describe those to an analyst. So for instance, in our product, we have a way to take a intrusion detection signature and provide a real kind of you know user level description of what that is. So instead of reading the rule and the text and the syntax of that rule, if you don't know how to read that, it's able to say like, well, this rule is looking for this sort of behavior, and if it happens in this way, then we'll generate this alert. So it's really just simplifying and making the workflow for an analyst easier, such that a less sophisticated analyst can kind of start getting into the level of data that we provide. It's an entry point, and then they can learn more and more and more and kind of advance their skills over time. And I think the LLM helps to kind of accelerate that.
So when it comes to alerts and rules and signatures, what's possible with an LLM that wouldn't be possible through manual processes? How does the time, the cost, the energy, the workflow compare between doing it manually versus doing it with an LLM?
Yeah, I mean, we've seen that creating rules and signatures and detections is still hard. I mean, it can help, it can assist perhaps in kind of tying some of those pieces together, but really just the ability to summarize and pull in other bits of information is pretty powerful. I mean, we've given it, for instance, let's say you generate 1,000 alerts and you give them to the LM and you say, what are some similarities, similarities of these alerts? Or can you tie together some, common threads about the types of attacks we're seeing and tell me where else I might need to look? The LM does a great job of kind of providing that context and giving some pointers. Doesn't do a great job when you say, hey, here's the type of threats I'm trying to look for. Can you write a rule for me?
So when it comes to tools like ChatGPT, how does Corelight go about ensuring customer privacy?
Yeah, so we've taken, I think, a pretty interesting and principled approach here in that, most of our customers are pretty sophisticated, large organizations that are risk averse. So they don't want us to be sending their data off to a third party, almost regardless of how that's going to be brought back to them. Certainly there's value, but there's a lot of risk in that. So we've started just by leveraging the fact that we are based around open source products mainly, and the LLMs have been trained on the way, the structure and the format of this data. So we're able to actually go take the data without providing, privacy protected information from our customers, but just provide the structure of the rule, maybe the name of the rule, and say it's using this open source kind of data format. And the LLMs respond really well to that. They've essentially been pre-trained on our data, which helps. So we feel like we've stepped into this carefully, but our customers, really like the output, and they're thankful that we're not providing, at least without, very clear, consensus from them, any sort of other privacy and related data.
In the context of fraud detection, how can network monitoring and visibility be helpful?
Yeah, so there's some definitely, I would say it's kind of an off-label use of our data, but we have several customers who have really leveraged this to make use of fraud detection in various ways. So by being able to profile the network connections in a certain way, looking for particular characteristics of the way they're connecting, the type of devices that are connecting, the patterns in which they're connecting, the way that particular protocols are being used, like HTTP, across, an API server or something, we can, easily understand and recognize patterns in those, and then that can help the security team and perhaps even the fraud and risk teams be able to understand where there might be anomalies or things that they need to look into. So while it is primarily focused, our data is primarily focused on the IT and kind of cyber world, we see some customers who recognize the power of having that level of visibility into their data, and they may not get it from anywhere else, right? So it's a nice secondary use, I would say.
So what needs to be done in order to obtain value for a fraud team or a risk team in terms of that pattern recognition? What know-how do organizations need to have, or what investments do they need to make with after after getting that raw data to actually extract the value from it in a fraud context?
Yeah, good question. I mean, so the first thing they need to do is actually have visibility into that data. So that means instrumenting your network in a way that you can get access to the security team or whoever's using that data to be able to see it, right? And that in our world now often means decryption. It often means placing the visibility at a point, around a web farm or around an application set of servers that are doing this so that you can actually see them. Then you need to have the context or understanding of how those things work. And that's often not a cybersecurity problem at all, right? That's going back to the application owner. That's going back to, perhaps the risk or fraud department who understands these applications a bit more. But like I said, they may have never had the sort of level of visibility into the inner workings of the network requests and responses and how that API looks from kind of the network perspective. So I think they're often going to be grateful that they have yet another place to be able to look at how that data works and be able to identify patterns that could be fraudulent.
So I want to get a sense in terms of APIs and other applications. What are some of the instances using the Corelight technology where you've been able to detect unusual activity, and how has that been beneficial?
Yeah, a couple examples. One was a large airline that was essentially looking for kind of abuse of their mileage plan. So they were able to identify particular characteristics in the API. One of the things is there's a unique identifier for each essentially customer, and that's kind of the unique key for their database that they need to be able to look on and reference. So just by extracting that, doing some kind of pattern matching against those, and understanding, oh, every time we see this, customer ID, we can tie it back to a network connection. It could be, whether it was this IP address or this set of users or services or locations. Maybe it's always coming from a particular country or something. And just by doing that, they were able to actually look into that traffic and start finding patterns and things that the application team hadn't noticed.
Interesting, really novel use. Vince, thank you so much here for the time.
Yeah, great to talk to you, Michael. Thank you.
You're very welcome. We've been speaking with Vince Stoffer. He is the field CTO at Corelight. For Information Security Media Group, this is Michael Novenson.